settle in and let's travel back in time. Not just a few years, but decades, to a moment when humanity held its breath. The year is 1970. The mission is Apollo 13. We're about 200,000 miles from Earth, gliding through the silent velvet blackness of space. For astronauts Jim Lovell, Jack Swigert, and Fred Hayes, this was supposed to be the third lunar landing, a mission that, while still incredible, was becoming almost routine for a world captivated by the space race. Inside the command module, Odyssey, the crew is finishing a television broadcast. They've shown the folks back home what it's like to live in zero gravity, smiling and joking. The broadcast ends, and the world tunes out, unaware that the real drama is about to begin. The astronauts go about their post-broadcast checklist. Life is calm, methodical. The hum of the spacecraft is a constant, reassuring companion. Then, Mission Control in Houston has a simple request, a routine stir of the cryogenic tanks. These tanks hold the spacecraft's lifeblood, oxygen and hydrogen. The stir is necessary to get accurate readings of the quantity levels. Jack Swigert, the command module pilot, flips the switch, and then it happens. A loud bang echoes through the module. Not a soft thud, but a sharp, violent jolt that shakes the entire spacecraft. The astronauts exchange confused glances. Was it a meteoroid? Did Hayes just pull a prank, venting one of the valves? The initial thought isn't panic, it's confusion. What was that? On the master alarm panel, lights flash. Yellow lights, indicating a problem. The voltage on one of the main electrical systems, main bus B, has dropped to 0. It's not just a flicker. It's a complete failure. This is serious. Power is everything up here. The astronauts are trained for countless emergencies, but this cascade of failures is baffling. Lovell looks out his window, and what he sees turns his blood cold. A gas is venting into space, a cloud of white particles shimmering in the sunlight like a swarm of fireflies. He radios down to Earth, his voice steady, betraying none of the fear that must be creeping in. "Okay, Houston," he says, and then utters the narration words. "We've had a problem here, down in Houston." The flight controllers are staring at their consoles in disbelief. Data is pouring in, and none of it is good. The pressure in oxygen tank number 2 is reading 0. Gone. But that can't be right. Instruments fail. It must be a sensor malfunction. The pressure in oxygen tank number 1 is also dropping, steadily, unstoppably. The reality is dawning on them. This is not an instrumentation error. The bang they heard was one of the oxygen tanks exploding. The jolt was the force of the explosion ripping through the service module. The gas, Lovell saw, was their breathable air, their source of water, and their electrical power, all bleeding out into the void. The Odyssey spacecraft, their ride home, is dying, and it's dying fast. The tone in mission control shifts. The calm procedural language is still there, but underneath it, an urgent, frantic race against time has begun. Flight Director Gene Kranz, in his signature white vest, addresses his team. "Okay, now, let's everybody keep cool. Let's solve the problem. But let's not make it any worse by guessing. His words cut through the rising tension. This is no longer a mission to the moon. This is a rescue. Back in the command module, the situation is becoming dire. The alarms are screaming. With the loss of oxygen, the fuel cells that provide power and water are failing. One by one, systems are shutting down. The lights flicker and die, plunging the astronauts into darkness, save for the dim glow of their flashlights. The comforting hum of the machinery fades, replaced by an eerie silence. The warmth of the cabin begins to seep away, and a deep, penetrating cold starts to set in. They are 200,000 miles from home, in a crippled spacecraft with a dwindling supply of power, water, and oxygen. The moon, once their destination, is now just a distant, indifferent rock. The only goal is survival. The command module, Odyssey, is no longer viable. Their only hope is the lunar module, Aquarius, which is still attached. It was designed to land 2 men on the moon, not to be a lifeboat for 3 men on a desperate journey back to Earth. The crew must move into the tiny lunar module, a craft with no heat shield for re-entry and limited power, designed for a 45-hour lifespan. They will have to make it last for nearly 4 days. The engineers in Houston get to work, scribbling calculations on chalkboards, running simulations, trying to invent new procedures on the fly. They have to figure out how to stretch Aquarius's resources far beyond its limits, how to navigate home using the sun as an alignment star, because debris from the explosion has made celestial navigation impossible. One of the most critical problems is carbon dioxide. The lunar module's system was built for 2 people, not 3. The CO2 levels are rising to toxic levels. The filters in the lunar module are becoming saturated. There are spare filters in the dead command module, but they are square. The openings in the lunar module's system are round. It's the classic square peg in a round hole problem, but this time it's life or death. Engineers on the ground gather every piece of equipment they know is on the spacecraft. Cardboard from flight plan covers, plastic bags, duct tape, and a sock. They have to design a way for the astronauts to build a makeshift adapter, and they have to communicate the instructions clearly, step by step, over the radio to 3 exhausted, freezing men in the dark. It is a stunning display of human ingenuity under unimaginable pressure. Against all odds, the improvised filter works. The carbon dioxide levels begin to fall, but the ordeal is far from over. The cold is relentless. Condensation forms on every surface inside the module, dripping down the walls. The astronauts can't sleep. They are dehydrated to conserve the tiny ration of drinking water. Their bodies are pushed to the absolute limit, yet they work, following the instructions from Houston, conserving every last watt of power for the final, critical moments of the mission. The journey home is a long, cold, silent coast. The world is watching, praying. Finally, the time comes for re-entry. They must jettison the service module, and for the first time, they see the full extent of the damage. An entire panel is missing. A gaping wound showing a tangled mess of wires and mangled machinery. It's a miracle the command module wasn't destroyed entirely. Then they climb back into the cold, dark command module, Odyssey. They have to power it back up for the fiery plunge through Earth's atmosphere, using the last bit of battery power that was painstakingly conserved. No one knows if the systems will restart. No one knows if the heat shield was damaged in the explosion. They jettison the lunar module, their lifeboat, and say their goodbyes to Aquarius. Now, they are alone in Odyssey, a tiny capsule hurtling towards Earth. The communications blackout of re-entry begins. The world waits. 3 minutes pass. Then 4. The predicted time for contact comes and goes. Silence. In mission control, and in homes around the globe, hearts sink. And then a crackle of static. A voice. It's them. They're through. The sight of 3 healthy orange parachutes blossoming against the blue sky is met with a tidal wave of relief and celebration across the planet. Apollo 13 had splashed down safely in the Pacific Ocean. They were home. The mission was called a successful failure. They never made it to the moon, but they made it back to Earth. The story of Apollo 13 is not just a story of a crisis in space. It's a timeless testament to human resilience, to calm leadership under pressure, and to the extraordinary power of teamwork. It reminds us that sometimes the greatest triumphs are not about reaching the destination, but about the incredible journey of coming home. Thanks for listening.